Hi, my name is Matthew West. This series of videos is going to be based on a graduate level statistics course that I taught last year. This video specifically is going to be focused on multiple regression using ordinary least squares estimation and doing this using R and R Studio. If you're new to R and R Studio, there are links below to download both of them. And throughout this video, I'll provide little points of advice and little tips about R if you are new to it. If you are new to R or a little inexperienced with multiple regression or maybe a little bit of both, this video will be good for you. Or perhaps you can even be someone like me who was kind of trained using something like SPSS and now you want to transition into R. So maybe you do have a lot of background knowledge, you just don't know how to do it in R. I hope that this video and future videos in this series will be helpful to you. The script file and the data that I'm going to be kind of using for this tutorial today are also available and linked below. So all of that said, let's get right into it. So kind of not surprisingly, one of the very first things that we're going to do is install a package. So this is going to be a very common thing that you might run into, especially if you are new to R. So this very first package, Rio, in this line right here, the install packages, is a way to install packages. Like everything in R, there's multiple ways to do it. So this is just one easy way to do it. We're installing this package called Rio, and we are going to use it to import data. Lots of different ways that you can import data in R. This is just one way that I'll show you. So if this is your first time, again, there might have even been like an orange line at the top of your script file that said, oh, you have a bunch of packages uninstalled. Do you want to install them? You can just click that and install everything here. I like to do it one by one, just so you can kind of associate what we're using that specific package for. So if you ran this line, and if you're using something like a PC, you can do Control Enter, and that will run the line. I already have this installed, so I'm not doing that, but you'll see things happening kind of down in the lower left-hand corner here in the console. And then after it's installed, if you already have it, we use this library essentially to call a specific package. So I want to use this specific package. That's all I'm starting with right here. Next thing we're going to do is actually import the data itself. Again, lots of different ways that you could do this, just point and click. Even there's a little button in the upper right-hand corner where you can just import a data set in a variety of different file types. This one is just going to be CSV, kind of an easy format to use and manipulate and use in a lot of different programs. So here I'll note a couple things. First, one thing about R, I'm naming this data because I'm a simple person. You can name this whatever you want. It's arbitrary. But I'm just, again, simple, so I'm just calling this data. So it's my data set, right? Easy to remember. This equal, not a requirement. There's another way of doing that. I just like the equal sign. It works better in my head. So I'm saying, okay, my data is equal to what? It's this specific file. So you're going to have to change this part for your specific computer. If you are on a PC, it might look similar to kind of what I have up here. Otherwise, you can kind of click on the file and look at properties and then find the kind of file location, then put it here. One small potential annoying thing, you have to make sure these are forward slashes, or I guess technically just slashes, but forward slash there to ensure you're specifying the right file. Again, there's other ways to do this, For example, you can set a working directory. So if you have a folder that you kept all your data in, or a script file, something like that, you could first do that. Again, I'm just going to do this kind of classic way of just specifying the exact file itself. So again, I'm on a PC, so it's Control Enter. Forgot exactly what it is on Mac, but it's roughly similar. Now, after I've run that, you'll see up here, now we have something that popped up. Okay, we have this thing called data, because that's what we named it, 500 observations and 4 variables. So we know something happened if you get the blue and nothing red pops up. Again, not always a terrible thing, but if you see red down here, that's normally a sign something didn't go the way you wanted it to. So there's that quick check. Also, a very simple thing that you would often do anyway with any data set is to examine kind of the basic descriptive statistics. So what I just ran right here, the summary data, and we'll use the summary function for other things as well. As the name implies, it gives us some basic key details of whatever we put here. So in this case, it's a data set. So you want to say, okay, what are, again, things like mean and median to get a basic idea. Always good practice to, quickly check things and see if it matches kind of your intuition or what you already know about the data. For these tutorials, I like to control a lot of things so we don't have any missing data. In later videos, we'll talk about more complex things. But right now, we're starting in a very kind of simple, ideal, and contrived scenario. So we have y is our dependent variable, and then all the x's are going to be the independent variables. One thing you could maybe note is this x3 variable is dichotomous. If you'll notice, we see a minimum of 0, maximum of 1 there. So that's your little kind of hint that that's a dichotomous variable. Next thing, actually moving to the regression model itself. The specific command here, lm, you can think linear model. We get one new sign. I think it's tilde. I'm not sure if that's how you pronounce it, but essentially that means regressed on. So we're taking this variable, right? We named it y. We're regressing it onto other things. So now we have plus signs, but these are our independent variables, x1, x2, x3. So now we have plus signs here. So we have some new symbols going on, regressed on, and then plus signs we always use for independent variables. Then we're specifying our data. Again, data is equal to data because we named it data. Again, if you named it something else, you would use a different name. And once we run this, you'll see basically we just get the intercept and our coefficients. Now, generally, you might know, even if you're, again, really maybe inexperienced and don't have a lot of knowledge, you might know there's maybe some more information that we need here and then we want to look at besides that. Well, we can get there, and on the way, again, I want to illustrate some things about R and kind of capturing this idea of what an object-oriented language is. So again, you'll see similar to how we did that data, when we said data is equal to this. Again, we could have named it whatever. Similar thing here. Again, I'm very simple. So I'm using a simple name, LM1, because I'm naming it. It's going to be my first linear regression model. And I'm saying, again, equal to something. And here, again, it's just a copy over of what we already ran. So essentially, I like to think about it, and a lot of other people, I think, use this metaphor that an object-oriented language, which R is kind of like boxes. We put things in boxes. We can take things out of boxes. We can stack boxes. We can put small boxes inside of larger boxes. And that's kind of the main idea. Again, we can put names on whatever you want. Like if you're moving and packing or something, you might have a box labeled kitchen, right? Because it's easier to do it. Still a box, the label we put on it is kind of arbitrary, but often we do it in ways that we can remember. So in this case, okay, it's my first linear model, LM1. So initially we run it and you'll see, okay, nothing happens down here besides the little blue, but you'll see up here in the right that now we have something else, LM1, and it's a list of 12. So first thing to look at, and I'm going to illustrate some other things we can do. Okay, it's a list of 12. What is that list of 12? We'll see it includes a lot of things that we would often be very interested in, like the coefficients. Now, again, more as a kind of illustrative point about using R and object-oriented language. Now we have this box LM1, and again, we just did the name, so we realize coefficients is in that box. We can now ask for specific things that are in that LM1 box. And we have a new sign here, the dollar sign. But basically that's going to say, again, in this box, or this specific thing. In the box that is LM1, money sign, I want the coefficients. Now, again, in more kind of reality, we could use that summary function again and get more core idea. Again, a lot of what I was just illustrating will be helpful kind of down the road, especially if you get into more advanced techniques. To illustrate, again, even more specific, right, we have the summary, right? So we can still do that. Okay, the summary of this box that we call the LM1, I want specifically the coefficients in that box. And here, another quick thing to illustrate, I'm asking for specific rows and column. So you read rows first, second row to fourth row, and I want the fourth column. Here, I'm actually just grabbing p-values. Again, maybe you wouldn't do this for a lot of conventional purposes, but later on, again, with advanced methods, often we're repeatedly doing things multiple times, and we want to grab specific pieces of information of that each time we do it. So it's a little bit helpful to kind of wrap your head around this stuff if you're interested in more advanced approaches and techniques. Again, basically to illustrate that we can keep on putting things in boxes, right? I can put that summary in a box, and we can look at, okay, what do we have? Now, again, a list of 11, we can look at what those 11 things are, and we can grab specific things like the R squared. To kind of illustrate, again, how this might be valuable to use is with model comparisons. So here, LM2, so second model, again, you can name it whatever you want, but I'm doing a second model, and you'll see here I basically just dropped X2. So we can do the same types of things that we did with LM1. So we just created this new box, we named it LM2, put the summary in there, and now we can grab R squared from both and subtract them to see the difference. So essentially, we lost some variance explained by dropping the X2 variable. Again, this is going to be relevant to like model testing, for example. It's relatively common with interactions that you might estimate a model without interactions first, then estimate a model with those interactions, and then test that R squared difference. So that would be kind of an example of how you could do that. And I'll show later even simpler way that you can test that. But this is why I think if you can wrap your head around a little bit of the language and how to use it, that's going to be helpful later on, even if it isn't necessary, again, if you were just running a single regression model from the start. So in the follow-up to this video, we're going to get back to some more of the key statistical things, which are specifically checking assumptions. So thank you for watching, and I hope to see you in the next part of the video.